Okay, so we're going to get into simplifying expressions. So this, I want you to just treat like it's just the square root of 363. So I want you to come back up here and find the biggest perfect square that goes into 363 and see what you get. Okay, so you should have seen that 121 was the biggest perfect square that goes into 363. Okay, so 121 times 3. So from here, I just split everything up. So I'm going to take the square root where I can take the square root. So I have 11. I can't take the square root of 3, so I'm going to skip that just for a second. I can take the square root of that. That comes out as just an x. This comes out as in y to the third, because again, don't forget this is a 2. So 6 divided by 2 is 3. 2 divided by 2 is 1. 8 divided by 2 is 4. Okay, so I have all of those. And then I have the square root of 3 under the denominator. And guys, notice I'm not worrying about this one. That one could have the absolute value bars on it, but, and I didn't say this a while ago, I should have said this. These only come into play, like when you have the absolute value bar, is when you are solving equations. That's when it's absolutely imperative. So think about, like, I just want to talk about this, like think about x squared equals 4. You know, if you have a problem like this, then you are going to, when you take the square root of it, you're going to have the absolute value bar around that. Okay, so let's go ahead and try these two. These two are the exactly like this one up here. And so see what you get. Okay, so I've set both of these up. I just want to talk about, there is a slight difference between these two down here. So this is the same. So that comes out as a 3. I can't do anything with that. So I'm going to hold on to that. Okay, so notice that this 4 divided by 3. Well, I can take out 1x, but I have 1 left over. So think about that. If I did like, if I took 4 divided by 3, 3 goes into 4 one time with 1 left over. So I'm going to take out 1x and I'm going to have 1 left over. 6 divided by 3 is 2, so I'm going to have y squared. So I am done with that one. And then this one, 11 divided by 3, let's see, 3 goes into 11 3 times with 2 left over. So I'm going to say z to the third. I'm going to have 2 left over. Okay, so let's go and see what's underneath the square root. So I have a 5. I have 1x right here. And I have 2 z's, or z squared. So this is my final answer. So see if you can do this one here. Okay, and this is your final answer for this one. Please be nice to me when you are doing these. Make sure that you put the roots where they're very easy to see and that you're not getting it mixed up with the exponents. Okay, so for our final section, we're going to find the domain and range of each function. So remember, we've had these before, so you cannot have a negative number underneath the square root. So we have to have x is greater than or equal to 7. So our domain is going to be, because it's equal to, it's going to be 7 to infinity. This one, we're going to do the same thing. I'm just worried about this, and I'm just worried about this here. So see if you can do. Okay, so hopefully you saw that you saw the domains, but now we're going to focus on the range. So I want you to think about, okay, so my x values, if my x value limit is 7, and I'm going to plug that limit in here, and what happens to my y value? Well, so when I plug in 7, that becomes a 0. The square root of 0 is 0. So my range goes from 0, and let's see, let's plug in another number. Let's plug in 8 or 9 or 10 or something like that. Let's do 11 because we're going higher because of that. So 11 minus 7 is 4. The square root of 4 is 2. So do you see, like, we keep getting bigger and bigger and bigger. So it's going to be not 2, sorry. It's going to be positive infinity for my range. So see if you can take that thought process and do these two here. Okay, so this one I found that if I plugged in my limit of 4 here, I would get 7. So I'm trying to figure out, okay, is it going to go from 7 to positive infinity or 7 to negative infinity? So I know that because of my domain, I have to go smaller than 4. So I just chose -2. So if I plugged in -2, I got the square root of 12 plus 7. Well, that's definitely a positive number. So then my range was 7 to positive infinity. Okay, so let's look at this one. So I plugged in -3 and I saw that my limit is 2. So I didn't know if it was positive infinity or negative infinity. So I went bigger. I went 1. So when I plugged in 1 here, I got 2. But then when I multiplied it by this -5, it became a negative number. So I figured out that 2 really isn't going to make it that much difference here. So it was smaller. So my range was negative infinity 2. And finally, what's nice about the domain and range of any odd roots, it's always, both of them are going to be negative infinity to positive infinity. So when you see this, you don't even have to think about it. It's just the same thing every time, no matter what kind of odd root you're talking about. You don't even think about it. So the even roots you have to think about, but the odd roots are always a set of all roots. Okay, and I think this is our last thing. So when evaluating rational exponents, you have to do the radical first, then the power. So we're going to do the radical first. So we have the cubed root of 64 is 4, and then 4 squared is 16. But notice this one. This one, if I took the radical first, it would not give me a real number. So then we're going to do this first. So this is going to be -4 squared is 16. Sorry, guys, I told you wrong. Okay, so what we're going to do is follow the order of operations. So we're going to take 2. Oh, goodness gracious. We're going to take 2 and we're going to raise that to the 1/2 power, because remember, this is the square root, so that's 1/2 power. So 2 to the 1/2 power, that's 1. So what happens is these cancel out and it's just leaving you with -4. Okay, what's happening here is that, notice these parentheses. So I have to do what's inside the parentheses, and I cannot take the square root of a negative number. It is undefined. So notice the difference here. Let me erase my mess. All this stuff is happening outside the parentheses. So I'm taking this 2 and raising it to the square root outside the parentheses. But here on that last one, because the square root is inside the parentheses, then it becomes undefined. So it's a little bit confusing, but we are done.